name is Jim Manico. I'm a professional secure coding educator. My job is I teach software developers how to write secure software. It is both a science and an art. It's a huge challenge. It's something I've been studying most of my life. I've been a board member at OWASP. I've been an educator for a couple decades. I'm an author in the secure coding space, and I help manage several OWASP projects because I love to add unnecessary stress to my life. Now, I like to help the community out, just like you do, as best as I possibly can. Now, I want to talk about artificial intelligence. I think that human beings who are solid developers, who are leveraging AI in software development,
Hey
are going to.
Jim, this is Aaron. Just wanted to let you know we can see your notes if you want that or not. No big deal. Just wanted to let you know.
How's that? Is that better?
It's great. Thank you.
In fact, actually, let me do one more swap. So let me stop share. Hang on for 1 second. Let me get this right. Let me swap displays. Let me turn sharing on one more time, and let me do it properly though. So I'm gonna
And
go.
seeing the notes is helpful to me. I'm just not sure if you're.
No, it's not. I want to share out this screen. So that's a bit better now. Is that so? You're seeing my main screen
Yeah, perfect.
in that. There we go.
Thanks, Aaron
So
and Sam, for the call out.
thank you for that. Let's take a step back though. So my basic thesis here is that AI is one of the most dominant technologies changing engineering, and it's not going away, right? And my belief is that AI is everything good? Are we good?
I think so. I mean,
Good,
it almost sounds
good.
familiar, but I've definitely never been
Used
there.
to be New York Pizza.
Oh, okay. I know where it
My-
is.
I'm going there. You want anything from there?
Right.
I
So
muted
here's my
you. Please go ahead.
here's my thesis. My thesis here is that AI is going to dominate software engineering, and AI is not going to replace the jobs of software engineers, but software engineers that are leveraging AI tools to do software engineering are going to replace those engineers who are not. Because what I'm seeing is about a 10x productivity gain for the average developer using modern AI software development tools. And the problem is a lot of senior developers are going to open up like ChatGPT, generate some code in a raw prompt, they'll see some bad results, and they'll give up on the technology. Now, when I give these talks at conferences, I almost always get one or two senior developers getting up and walking out in disgust when they see AI doing this kind of work. They think it's garbage because, again, almost every single scientific study on AI for code generation that we see at the big universities, they're grabbing raw prompts, generating code, they're seeing it's done poorly, and then they dismiss the technology. And this is foolishness. And I'll even go as far as saying, if you're a software developer or a company that's not rolling out AI to aid in software development, you're crazy. You're nuts. The productivity, functionality, and security gains are off the chart. But like any tool, especially bleeding edge tools like artificial intelligence tools, we got to use them properly. It takes a little bit of work, right? And so we're going to take a look at how to use AI for code generation, not in some abstract, floppy way. I'm going to get specific with you. I'm going to look at the most modern web user interface framework, which I think is React, a relatively recent version of React, and show you how to go through the path of taking security knowledge of that framework, which we still need, and converting that into prompts we can use to assist AI in generating not just garbage code or React code, but high quality, well maintainable, and secure React code, right? And so we're going to look at how to create these AI prompts for the React security domains. I'll cover a few of them, right? We'll look at some key concepts and some challenges with each of these risks and the different protection strategies that you need to understand as a human architect. And then we're going to convert those security requirements into prompts. And I'm going to show you some live demos of how this works out and different AI engines of the day, live in the cloud. Wish me luck, So, yeah, I'm Jim. We did that already. So let's get into it. Now, my belief in how to do a secure AI code generation lifecycle is number one, I need human experts, like someone in chat mentioned earlier, right? And by the way, I'm not looking at chat. If you have a question for me, just pop your mic on, interrupt me, and ask the question. I'm not going to look at chat until the end of the presentation. So number one, we need human experts. I want a human expert to create verbose security rules for each of your frameworks. And if you don't have human experts in security driving software engineering, you're kind of screwed anyways. You've given up on security at this point. Without human experts driving the software development lifecycle, your chance of secure software is zero. Ain't gonna happen. So having security experts integrated with development staff, that's not going away. But the problem with that is your software security experts, they show up, work for a bit, and often leave. They're highly sought after professionals, and they can make a lot of money somewhere else. So they show up for a while, they can move on, and if you're lucky, they stay. But even if they stay for a while and leave, they leave with their knowledge. So what AI used effectively can do is, when you have these various security experts showing up in your software development group and leaving, you can preserve their knowledge by getting them to write actual security rules that will stand the test of time for each of these frameworks. And then our job is to take those human security rules and run them through AI engines to convert them into AI-specific rules. So I start with really detailed verbose rules and bring them down to a more concise rule that I know AI is going to actually understand, and I'll test it out. Then I'm gonna open up a prompt or open up whatever my AI tool today is, and I'm going to dump all my rules for that framework into my AI session, and then ask AI to write code for me. And then I'm going to apply all of my rules again after I generate a code. In my experimentation, I find that some of the rules fire better up front. Some of the rules fire better on existing code. So I apply the rules, generate code, apply the rules again, and then I'm going to do standard security review. I'm going to run SAST engines, run me some SemGrep, run me some DAS scanners, run me some code quality scanners for like highly critical crypto or authentication code. I may still have human reviewers, but I'm not going to blindly let any human or any AI agent write code and push it live. I'm going to have a review process. We call this DevOps typically when we use a lot of automation to do code review. And I think that's the minimum bar in software development. Again, I'm not trying to cause trouble, but if you're not using AI, you're not using security scanning tools, you're not automating this process, you're really way behind in terms of modern techniques when it comes to leveraging modern tools for software development. It's like you're driving down the LA freeway, but you're in like, you're like in a 1960s level car. And you may have fun, it may look pretty, but you're not going to outperform any of the modern vehicles on the road in any way, no matter how pretty those old vehicles work, LA people. Let's move on. So number one, I want a human being to create good security requirements. We'll look at that in React in just a minute. And again, I may not have that expertise in-house. Get a consultant to show up who is good at AppSec in that framework, even just for a couple days. Pay them what they want and preserve their knowledge by writing rules that you can reuse in the development lifecycle for all of time and space. Awesome. Next, we're going to convert those requirements into AI rules, probably using an AI engine. Like I'm going to ask AI, hey, here's my super verbose human rule on how to do something secure in React. Can you help me convert this to a rule that will still preserve that knowledge, but you're going to understand as an AI engine to generate code? No problem, Jim. Here you go. And I get really good results. I take the human rule, I put that under source control, and then I'll have a different AI rule for each engine. But I keep two sets of rules within my source code repository. You want to preserve these rules under a standard code repository. The original human rule, and then the AI generated rule for each AI engine that I might be using. And then I apply the rules to my prompt of the day. If I have enterprise AI software, I may apply these prompts globally to like all my developer prompts. But what a lot of the enterprise tools won't let me do is apply these rules both before and after code generation. And when I'm applying the rules both before and after code generation, especially for larger code bases, the difference is significant. And I'm going to iterate, right? These rules are so important. They're even more important than source code at some level. So I'm going to take these rules, put them in GitHub in a private repository, and have my developer leads and security leads maintain and fine tune these rules over time. So when they all leave, the next generation of developers in my organization can still benefit from all that security expertise, something we've lost over the decades that we don't need to lose anymore. And so here's an example of some of the rules I'm going to do for quality, right? First of all, I don't want to write code or have AI write code that's hard for a human to understand. I still want human reviewers for certain kinds of code. So I want to ask for a very low cyclomatic complexity when I'm asking AI to write code for me. This will measure the number of linear paths that can go through a code, that can go through a block of code. The lower the cyclomatic complexity, the easier it is to maintain that code. I'm also going to ask AI to generate low cognitive complexity code that's just straight up easy for humans to understand. Like, if I could go back to the version of me that wrote code 15 years ago, I would take me on a roof and bop me off the roof to eliminate me from the human pool, because I used to write code on purpose that was super complex to prove how cool I was. And that is awful. Oh, that is the worst possible kind of developer. They got skills, they know what they're doing, but they're purposely writing clever code. Clever code is awful. Clever code is garbage. It's hard to maintain. I write code after 30 years of being a professional, I write code that's simple, maintainable, easy to read. So the next person, my old boss told me, hey, Jim, assume the next person maintaining your code knows where you live, knows who you are, and is a psychopathic maniac. So write code for that person. I'm like, that's a great mission. I want to make sure the next person reading my code is not going to hunt me down and eliminate me from the human gene pool. So this is how to take that concept and have AI write code in that way for you. High cohesion is a good one. It indicates how well related the responsibilities of a module or class are. So high cohesion will give me a couple benefits in terms of building individual modules that are straight up easier to maintain. And here's the rules I have set up here, right? This is the exact prompts I use. Like for high cohesion, ensure that components, modules, and functions are logically grouped, making the code base easier to maintain and extend. I don't want messy, a poorly grouped collection of code modules and similar. And cognitive complexity, reduce the mental overhead required to understand the code by writing clear, concise, and well-structured logic. And maintain low cyclomatic complexity. Write code that has low cyclomatic complexity, easy to understand, test, and maintain, reducing chance of bugs. Again, smaller number of linear paths. Some other best practices are be specific, explain why you're asking for this code, include constraints if they're in your requirements, actually provide good code samples. Like I like to do URL validation in React. We'll talk about that in a minute. And until I had the rule specify that validation function, AI would give me a lot of variance in what that protection function was. And for certain protection functions, I want it specific. So I'll put a code sample into my rule. I want to ask for explanations. If I'm not getting what I want back, I'll say, hey, why did you write code this way? And how can I get you to write code that way? And I'll get an explanation, change my prompt rules, and I'm good to go moving forward, right? You got to iterate slowly and refine. Again, these rules are worth putting into code repositories to be maintained in and of themselves. They're so powerful. I digress. Let's go back to React. So now React is the leading JavaScript library to build web applications. It's used for mobile and desktop. I'm going to focus on React for a web page. My career the last many years. And so React, there's two things I'm worried about. First of all, with React, in client-side React, all the code is running in the browser. So my first attack is to go view source, and I can see bad stuff in the code. For example, I might see a hard-coded API key. I might see access control. Like, how much access control should you be doing in React? 0, because I can view source and see everything anyways. Like if I'm saying, oh, if you're an admin, then show the key. I just view source and I can see it all anyways. So when I'm looking at React client-side code, I never want to see a hard-coded secret because the attacker can see all your source code, damn it. No access control at all. There's client-side access control is a failure in almost every case. I want to stop using old lifecycle methods in React, and don't allow developers to manipulate and edit the DOM directly so we don't circumvent React's automatic protections. I don't want to use things like the eval function on a variable that's going to execute user input as code. And we get into the nitty-gritty of React. I want to do very specialized validation with the prompt and type arguments of the main create element function within React. And I don't want to put sensitive data in client-side storage like local storage or session storage. That's a bad practice. That can be stolen pretty easily. I don't want to use old school or poor third-party libraries, one of the biggest problems in modern development. And I don't want third-party libraries misused. These are all the things as the attacker I can see you do just by going view source. So let's take a closer look at how React stops cross-site scripting. Let me show you one attack, right? This is a standard attack where suppose I have like a profile description in a social media site, and I post this to my social media profile for my profile. And then Panda looks at my profile, and if that web page is not properly securing my profile description, then when she looks at my profile, this runs raw, and I can use this attack to steal data from a web page, like stealing a cookie or stealing any other information that you've embedded on a web page in some way. And there's a lot of other attacks. Like I mentioned, I can steal data from local storage with cross-site scripting, otherwise known as content injection, where I can harvest, again, I post this content to a website that someone else looks at without security. The flow is usually I submit the content to a website, that lands in your database, an evil script, JavaScript, some other user visits a web page that renders my data, my script data that I submitted to your database. And if that page is rendering that data raw, then I, as the attacker, I can get my JavaScript to execute in somebody else's browser, and that's a problem. I can do things like, again, harvest local and session storage, and in one shot, I'm going to grab local and session storage, I'm going to add it to a URL and send that to a website that I control as the attacker. I look at my logs, and I'm getting all the sensitive data out of your browser for this application. I can also do things like set up a keystroke logger in JavaScript, and for a certain page, trap every keystroke. And by the way, the most unethical team in American football would be the New England Patriots. They're foul, cheating bastards, all of them. Now, any other team in the American Football League is ethical. So in this, I have document body inner HTML with my little editorial about football, and it's going to fully deface the site if my attack lands in your web page raw without proper security. And a lot of people try to firewall this away. Good luck with that, because in JavaScript, I can represent attacks with no letters or numbers, and I can even make it more obscure. JavaScript is a wacky language. It's really hard to firewall this stuff away. You set the rules too strict, and it's blocking good data. You set the rules too loose, and I can attack your site. So we need a better way to handle cross-site scripting than some kind of firewall rule. That's fix your code. Come on now, fix the code. So what we have in React is called JSX. This is a user interface templating language for the web that automatically escapes output. So one of the attacks we looked at earlier looks like this right here, right? Where I'm stealing a cookie and I'm sending it to another server, my evil Manicode server. And when you put that data in JSX within Mustache and a user interface template, it's going to escape that content. So the content will be displayed on the page, but it's no longer going to execute the attack. This is the heart of web defense to stop cross-site scripting. And my prompt for this is encode user inputs. Always place user inputs inside JSX with a curly brace to prevent an XSS attack. Avoid unsafe methods that bypass React's escaping mechanism. Rule number 1, to make sure we're building React securely. The other part about React is I'm going to often use create element, and there's 3 arguments. There's a type, that's the HTML tag. There's the prop, those are our attributes. And then there's the content. And the content, like we just looked at, that's going to get escaped. And that's wonderful. But the first two arguments will not be necessarily. And if that's user input landing in these arguments, then we got a problem. Like here's an example of an insecure property. If this is driven by user data, this data lands in an on-click function that executes code. So some use of props, if they're landing in the wrong attribute, are going to be dangerous. If you put a prop in a safe attribute that doesn't execute code, you're going to be okay. And it's like, here's my big list of safe attributes. Here's my big list of dangerous URL loaders that require some special handling. And here's my prompt rule for this. Validate, react, create element types. Ensure only safe, expected HTML tags or React components are used. Avoid dynamically generated or untrusted input as a type argument. This is a core part of building React components, and this will instruct AI to do it safely. That second argument is a prop, right? So validate props. Use the prop types in React to validate all your props. Avoid passing props directly into executable attributes like onClick or onload, like we just saw. Sanitize and escape props in URL-related attributes like href or source. We'll get to that more in just a moment. Now, a lot of things can go wrong in React. There's a lot of mistakes we can make, like using dangerously set inner HTML. If you're using that function, it's named dangerously on purpose. We don't want you to use it, or be cautious when using it. I can use a JavaScript URL to bypass React's escaping. Sometimes if you're doing a styled component, developers don't escape that input properly. And there's other things that can go wrong. We're going to look at a couple of these and then do a bunch of demos. So I want to start with the main way websites are attacked with cross-site scripting. I track the work of Google a lot. They're one of the best researchers on the planet with this stuff. Michelle Spagnuolo and Lucas 𝗔𝗂𝘁 are my heroes. And they tell me that over 1/3 of successful attacks against Google properties are JavaScript URLs. So, and there's no easy way to disable JavaScript URLs in a website, in a web page. I actually submitted, with someone else, I submitted a suggestion to the W3C, give me a response header to disable JavaScript URLs, and they unanimously said no, except for a few. So unanimously said no. Let's leave it at that, be more accurate. So we have to handle this ourselves as developers. By the way, Angular handles this problem automatically. And let me show you what I'm talking about here. I may have a user web page where I'm going to render your home page. This is JSX. This is how React builds a link. I have an anchor tag with an href attribute. There's the user's homepage that they typed in. I typed in Jim's cat pictures. I'm a cat person. I love cats. And I got the homepage here. That's the link. So it's going to take my input, my domain, and put it in a link like this. And by the way, if you're going to do this, any kind of linter is going to complain. They're going to say, hey, I'm doing it right here, right? Hey, don't do that. Script URL is a form of eval. It's a way to execute code. So you shouldn't do this. So linters know about this. But this is a way I can bypass React. One of the most common ways I can bypass React. My attack would be JavaScript, document, body, inner HTML. Dogs are awesome. And this is actually a legal URL. So if on the server, a developer is checking, did they submit me a legal URL? If it's a yes, that a JavaScript attack URL is actually a legal URL. And here's another example of this. Here I have an example where I have a payload that's a URL lands in JSX. It lands in the mustaches in a form action. It gets escaped, but a JavaScript URL, even if it's escaped, will still execute. This is complicated, but the whole point is, if I'm going to take user data, that's a URL, like you let the user type in the domain of their company or the domain of their blog or their Facebook URL, and you're going to then render it, it's not enough to check if it's a legal URL. In fact, what I recommend we do is we validate in React itself. So when I'm going to render a link in React client side in the browser, I'm going to make sure that URL is legal in React itself, emulating what the Angular framework does for web development. And I have this function here. validate URL, make sure it's a legal URL, and make sure it's HTTPS, or don't link it up. Don't render it. And I have a more advanced version of this rule that only limits a domain or lets me extend the protocols and does some more validation. This is just fine though. But if I'm doing more advanced mechanisms, I may need a more detailed function like this. And so here's my rule. Accept only secure URLs with correct syntax. Validate any user-driven URLs used in client-side React code on the client and replace a URL with the pound. If it's not valid or HTTPS, use the native JavaScript URL class and not a regex for this purpose. Here's an example of the function to use, code sample, of the minimum of what I want to see. So let me show you one more rule, and I'm going to give you some demos. The next thing is about rendering HTML. In web development, we might want to use a WYSIWYG editor as part of a web form. There's a bunch out there. There's CK Editor. There's a tool called Freola. And here's the old school one, TinyMCE. It converts the text area in a web form like that into a WYSIWYG editor. And I got the bold, I got the images, I got bullet point lists. I can even change the colors of fonts. It's a party. When I hit submit, it's a big chunk of HTML. It's trivial as an attacker for me to modify this and do nasty stuff with HTML. But if I put that HTML in mustaches in React, it's not going to render the HTML. It's just going to display the HTML on the page. And I actually want to disable React's escaping, and I want to actually render the HTML. That's the purpose of using a WYSIWYG editor. And the way developers do that is, again, if auto-escaped raw HTML, it just looks like HTML on screen. So React developers use the function dangerously set inner HTML that disables auto-escaping, and like the function name alludes to, it's dangerous. And we want to sanitize untrusted HTML before we let React render it. So I'm going to use a tool called 𝗏𝗏𝗺. That's one of the more famous client-side HTML sanitizers. And my rule is, if I'm going to use dangerously set inner HTML, then I'm going to 𝗏𝗏𝗺 that content, right? And I can configure 𝗏𝗏𝗺 to limit domains and stuff like that. But the long and short of it is, I do not want to use dangerously set inner HTML on raw user-driven content. I want to use dangerously set inner HTML on user content that's gone through 𝗏𝗏𝗺. So here's my rule, nice and clean. Minimize the use of dangerously set inner HTML. Avoid this method unless necessary, and sanitize content with trusted libraries like 𝗏𝗏𝗺. So this is the whole concept of taking the rules that we know about and using these rules to generate code. So I'm saying here, create for me a React user profile page with a username, first name, last name, homepage URL rendered as a link, and a profile description field displayed as HTML from the user, and please use a raw prompt and drop any rules. I'm using my account and saying, please ignore my account. Pretend this is, because I have so many rules in my account. Just say, use a raw prompt. And what would you do for the average developer? And here we have this big chunk of insecure code. I got a URL and an href. That's a really bad practice. Here's like user HTML landing in dangerously set inner HTML with no security. There's two major vulnerabilities generated by ChatGPT 4.0. Horrible. And so what I do is I say, here we go. I'm going to apply these rules. Strict URL validation, accept only secure URLs that are HTTPS. The same rule we just talked about. There's the function. And then minimize the use of dangerously set inner HTML. Avoid this method unless necessary, and sanitize content with libraries like 𝗏𝗏𝗺. And here's the new code that just got generated. I ran this a couple minutes ago, right? So we have the validate functions right there. I see that the user URL is being validated before it's rendered. That's beautiful. I see that 𝗏𝗏𝗺 is now sanitizing the description. It's like night and day. Let's look at this live in another engine. Let's look at how Claude has actually become really advanced lately. So let's see how Claude's going to operate here. Hang on for 1 sec. I want to grab my little demo page here. So let's try this in Claude live. Hey, Claude, create for me in React user profile page with the username, first name, and similar. Let's see what Claude is going to do here for me. All right, Claude, what do you got for me? Get to work. So you're going to render me, what are you doing? You're rendering a user homepage. What's going on here? Come on. There's the user object. What's going on? Hello, where'd you go? I want to see this user profile component. Error with the artifact. I want to see code. Here we go. So now I have user first name, user homepage. Is there any validation happening? I don't see it. Homepage URL, user description being added raw with dangerously set inner HTML. Absolutely no security in this. So I'm going to apply my rules live now, right? Remember, before and after. So I'm going to reply to Claude and say, dude, come on, fix this stuff, please. So I'm going to update user profile with your rules, Jimbo. And right away, there's my validation function. There's the homepage being validated. There's the user description being sanitized. So even in some of the top modern engines in AI, they're making what I think is relatively foolish security mistakes, even these latest slick engines. And by applying relatively straightforward rules, if you have the knowledge of how to use these frameworks securely, you transform your AI. You transform your AI generation from so-so to stellar. Now, if you want to experiment with this, if you look at the ChatGPT marketplace here, let me see if I can, let me put this over here for a second. Let me hunt this down for you. So what I've done is I've taken all of my rules and I put them in a GPT called the Secure React Architect, right? So I have like about 100 rules I'm using to get this right. So you can go check out the Secure React Architect in the OpenAI marketplace to experiment with some of this technology, right? I'm going to release a new one soon. This is for version 18.31 code. We have React 19 out. I'll push a new one out relatively soon, but that's my story, folks, is we don't want to use AI raw. We do want to use AI to generate code. Crazy if we don't. But we don't want to use it raw. We want to capture the existing brilliance that we already have in our teams. Someone out there is good with security. We want to take that user's knowledge, convert them into prompts, and use the prompts before and after development with AI to really encourage AI not just to write more maintainable code, but also to write more secure code. And if you experiment with this concept, I think you're going to find that the difference in using AI for code generation is like night and day. And so a few other notes, right, is that, I want to use React's built-in security and UI security methods described in this course to account for security issues that JSX does not solve, like the URL in JSX needs manual intervention. You can also add content security policy. There's ways you can design React to be more secure, that we can extend these rules even further if you have specific design methodologies you prefer. So I have a couple sets of rules. I have my rules for just maintainability. I have my rules for security. Then I have specific rules for each project if there are certain design methodologies that we want for each project. And again, we're basically taking the existing expertise that we have within our organization and converting it to rules that we can refine and reuse over and over. So we're not just accelerating developers' productivity, we're doing it with increased maintainability, better security, and better code than humans can write. And this is very controversial. People walk out of the room when I say this. When they apply the techniques and experiment with it, the difference is night and day.